Yeah, this is measure Odyssey. Measure Odyssey. Yeah, according to the assignment at hand, my area of specialization is physics. Yeah, and I will be tackling the covered in senior to second term mechanical properties of matter. Mechanical properties of matter. Yeah, I could make it somehow kind of big and everyone gets mechanical properties of matter. Okay. Mechanical properties of matter. And topic 2.4. Topic 2.4, it is the effect of forces on bodies. Effect of forces on bodies. Effect of forces on bodies. Yeah, before we go further, I'll give you the introduction. Our introduction will be in series of definitions, and yeah, I will just pick another color, something like introduction. Our introduction will tackle force. Yeah, definition of key terms. Definition. Yeah, sorry about the spelling. Definition of key terms. Definition of key terms. I'll be using the latex typeset for equations. Those who don't know latex, you check out the YouTube video. There's another definition of latex and latex typesetting. So I will start with force. What is force? Force is a pull or push that changes a bodies. It's a bodies, not the double bodies. A body's state of rest. Sorry about that. Rest or uniform motion. Yeah, that is our definition number one. You may wonder what is a body, what is a state of motion, what is a state of rest. Yeah, I could come and I give you a highlight. I would say this is our body A. Sorry about that. Let me get a rubber. You rub that one. So I will say this is our body A. This is our body A. Then I could somehow make it kind of big. Body A. This is our body A, and its state of rest. Yeah, its state of rest. Let me take a text here. If a body is moving with a velocity or speed, some kind of big, balance the board. If a body is moving with a velocity u greater than 0, this means the body is moving at any speed. Its state of rest is motion. Its state is motion, not a state of rest. Its state is motion. Then we could say if a body, these are our two conditions. I could write here another condition. If the velocity of a body is 0, then the body is said to be at rest. At rest. So as we investigate the effects of forces on a body, we shall come into other terms like inertia. We shall come into terms like momentum. Some going to tell moments of forces, and yeah, more. We shall get in more as we go in the way. So I'll start with inertia. Before I define inertia, we could say bodies. I could first write a paragraph here in another color such that you can distinguish. Yeah, I could say bodies usually have a tendency to resist the change in state. Yeah, to resist the change in state. Assume a bicycle is there parked. To push it you have to put a force, and to pull it you have to put a force. If your body is moving, if your bicycle is moving at a certain stage and you want to stop it, you have to put a force. So that is the change in state. State can be motion or can be rest. That is why I defined if I had our certain states of velocity greater than 0 and velocity equal to 0. So we can say inertia thus is the tendency let me write tendency of a body to stay in uniform rest or motion. Yeah, that is inertia. We could go into at another term called momentum. Yeah, what is momentum? Again, we change our color to another color and we say momentum. Before, I usually first give you a scenario before going to what I wanna say. I could come and put a body. Sorry about that. Is my rubber? Yeah, my duster now. So I could come and put a body A, and I say it's moving. Yeah, I could draw an arrow and I say it's moving this side with a speed u. Then we have a point. It's going from a point. We have a point A. If I could put here a point A, then we can say the distance of a body A from A to B. Or I could put another line, something like a dotted line, not to join our usual line, and I could come and I start it from here to here. So I could say from our point A to the body, this is our body B. From our point A to the body B, there is a force. The force acting on this body, we say the force is anything that changes a state. Let us say someone puts a string and is acting on the body. The force acting on the body is giving it a velocity u and something with an acceleration. We shall come into contact with acceleration. Then the perpendicular distance is a. So I could say moment here, momentum is the product of force, is the product of the force F, of force F, then times, where is my times sign, times the perpendicular distance from the action of point of force. Where is our action of point of force? I could bring another text and I put here a 0 such that someone can know this is our action of point of force. I could put a 0. Yeah, action of point of force F. Yeah, action point of O. Yeah, that is somehow. I could go and I insert another page to insert page after. Yeah, we continue. Someone is going to ask me, I said something about acceleration. Yeah, simple. This is senior 2 second term, no going into further things. Acceleration, I always first give a scenario. We can say, if we can give our if condition, if a body moves from A with a speed u and goes and reaches a point B, with a speed v, then let me first give a graphical representation of this. I could come and I say, let me use a rectangle. Now I'm tired of using boxes. This is our body A and I don't want it dotted, I want it standard. Rubber. Where is our rubber? Yeah, let me rub and I put our body. This is our body A. Where is my text? And it is moving from a point 0. Now we are saying if a body moves from let me not name of our body, let me leave it as our body, let me call it body. I don't know what we lose. Then I say it's moving from a point A. Then I come and I draw my arrow and I say, sorry about that, I draw my arrow and I say here is where our body is going. It's moving with a speed, I need a text, not that one. It's moving with a speed u. Then our body will move up to a point B. By the time the body reaches a point B, Control Z, sorry about that. Let me make it dotted. By the time our body reaches a point B, text, it will have a speed. It will have a speed of V. Yeah. By the time our body reaches there, it will have a speed of V. Yeah. So the change in motion is the total change that occurs between this scenario, the total change that occurs from here to here. If that was our change, someone can say our change, Control Z. Let me use a text, it's the one, our change delta V. Yeah, those who know the delta sign, our change delta V. I have written it poorly. Let me put another one and I say, yeah, that one could work. Delta V, our change in V, which is from U to V. So if I could write a statement and I say the speed of the body changes from U to V. The distance covered will be, we are going from a point A to B, will be B minus A, and the time taken will be T. So I could come and I say, therefore, thus acceleration in this case will be the rate of change of speed, because we are linear. We are not taking graphical terms, we are not taking velocity, we are not taking vector terms. Thus A equals, let me type some mathematical function. I saw something there like latex type site. Yeah, I will write a math function here. I will say thus A equals, those who know latex, flag. I'll write something like here, I'm not sure if I remember it well. Flag change in velocity, which is V minus U. I close, then I also put another, then out of time. This is latex. Those who don't know it, is a certain video on my channel. It shows how to do latex equations. So I could come and I put this one here. Yeah, I could make it kinda big. So what I've done, I've just got our acceleration, which is A. So I could say here where A equals acceleration tab V equals final velocity, then U equals initial velocity, then T equals time taken. Yeah. So finally we shall see that this is my last, this is where we shall start again next lesson. We shall say every motion in the physical plane where we are, in the physical plane, is usually determined, sorry about this, is usually determined by the laws of motion. So what will be the exercise? The exercise will be discuss and give graphical sorry about that, graphical representations of the 3 Newton's laws of motions. Newton's laws of motions. Yeah, your thing will equate to 20 marks, your discussion. Yeah, I think that is it. So before we go, I can just give a summary of what we have done today. Summary, if I could give a summary, we have discussed number one, what force is, which is a change, a pull or push that changes a body state of rest. Number two, what inertia is. We have established a relationship between force and inertia. Yeah, I think that lastly we have talked more on the effect of forces on a body, effect of forces on a body, where we can say forces change the state of body's rest or uniform motion. Yeah, and that is it.